Okay, so if you are my online students listening, we just did this practice problem from homework 10.2 number 7. And this is a good example of 10.2, which is going to transition us into 10.5. So you can pause your video and take a look at that. And now we move on. So to start with, we were a little rushed at the end of last class with complex fractions. So let's start there. Complex fractions in 10.3 is really just a mix of our multiplying, dividing, adding, and subtracting skills. Okay.
Is this the last unit?
This is the last. This is 10.3. Okay. Yeah. So this is the end of the homework that's already posted. Okay. Before we haven't moved on to new, we just want to pick up where we left off because we were a little rushed.
So wait, is there going to be another homework posted?
Yes, there'll be one more homework posted for what we do today, which is equations. Okay. Equations and a couple of word problems. Okay. Actually, the word problems we do today aren't too wordy. It's more about manipulating formulas. Okay. But you'll see that 10.5, 10.6. That'll post right after class. I want to see how far we got before I posted it. So it'll post by 12:15, latest. Okay, so a complex fraction looks really messy. It's all these fractions stacked up, but it really involves skills you already know. It's just a different way of writing division. PEMDAS, order of operations, matters. In PEMDAS, if you've got a rational bar, order of operations says simplify anything you can on top, if there is, and simplify anything you can on bottom, if there is something to simplify. Simplify those separately, and the last thing you do then is divide. A rational bar is like parentheses in PEMDAS. Okay, it's a grouping symbol. Now, so I don't need parentheses around these. These basically say deal with these and deal with these separately, and then divide. So all we're going to do here is we're going to take this complex fraction, which is just a fraction divided by another fraction, where we don't have parentheses because instead of parentheses we have this big grouping bar, this big rational bar, and let's just write it horizontally. So it's not as ugly looking. So we take the stack down a notch. But to do so, if we're going to remove this stack, change that into division sign, then we're taking away that grouping symbol, which means we need to put the other grouping symbol in. Okay? Basically, this grouping symbol right here stands for parentheses we don't have to write. But if we're going to make it horizontal, we got to put in the parentheses. Now we write it horizontally, we're not flipping anything, we're not changing anything, we're just instead of vertically, this divided by this, we're writing it horizontally, this divided by this. Okay? So write x plus 3 over 12 in its parentheses, that's the numerator, the old numerator, and instead of a division bar and stacking it, we're going to write the division symbol, and we're dividing it by this. Not flipping it, it's still division. We're just doing this divided by this. 8x minus 10 over 15. We haven't done any math yet, we just changed our notation. We changed the way we wrote this division problem. Now, when we want to divide this divided by this, we're going to have to flip and factor and cancel. But before we do that, we have to honor these parentheses. And anything that's inside the parentheses, we have to clean up first. Now, inside the parenthesis, how many rational bars do you see? 1. And what about here? 1. That's your goal. When you have one rational bar, you can drop the parentheses. So in a sense, these parentheses weren't technically necessary to begin with, but for consistency, lock them up in parentheses, write them horizontally. When what you have is in the parentheses, then look at what you have. If it's a single rational bar, you can drop the parentheses because there's nothing to clean up. Unlike here, the one we'll do next, see how there's a plus or a minus? That means we're going to have to do some adding or subtracting first to put this with a common denominator over one rational bar here with common denominators. But if there's no plus or minus in between, yeah, there's plus here, but it's just in the numerator. The point is that's one rational and one rational. Then there's nothing to clean up, nothing to add and subtract. No common denominators necessary. Huh? So I'm going to go ahead and drop the parentheses in this case. Now, you always want to flip before you factor. It's not mathematically wrong to factor before you flip, but often when you factor first, then you forget to flip. I know I do. I start if I try and factor first, I start canceling things out, and that's an illegal move if I haven't flipped yet. So all I'm going to do, I drop those parentheses. Now let's flip it. So x plus 3 over 12, I'm multiplying by the reciprocal. Now, multiplying, all multiplying involves is, boom, draw that line across and you multiply, but don't do it yet. You can't do that until everything is factored. Okay, once you have everything factored, then boom, you multiply, you create one rational bar. So everything here needs to be factored or locked up. Is there anything to factor here? No, but go ahead and lock it up. It's linear, no GCF, lock it up. It either all goes or none of it does. Over 12 times 15, nothing to lock up or if it's just a single thing, a number or a variable, you don't need to lock it up. And there's nothing to factor. If it had a square, like an x squared, you might want to expand it to xx to make it easier to cancel out, but nothing to factor. Here, anything to factor here? Yes. Yeah, we're going to pull out a 4x minus 5. Written horizontally, checked for one rational, good, drop the parentheses. Multiplied by the reciprocal, we flipped, fully locked up and factored, and so now, boom, we're multiplied. And your only job now is to put it in lowest terms. Lowest terms just means canceling out factors of 1. What do you see that matches? Yeah. Got 15 and 12, we can divide those both by 3, right? Leaving behind 5 and 4. Okay. Now, can we cancel out this 4 and 2? No, they're on the same level. Yeah, it's one on top, one on bottom. Right. Bless you. So I think that's it, but once we clean it up, we want to just double check. On top, we've got a 5 and an x plus 3. Always put the free-floating stuff in front of anything in parentheses. You don't have to distribute it, but it should, to your eye, it should look like a distribution problem. And on the bottom, we have what? 8, right. Remember, this is all multiplication. Once it's fully factored, it's all about multiplication. So any numbers that are left, you have more than one number, it gets multiplied. 8. And then 4x minus 5. Before I walk away, anything matches that I missed that can still cancel out? No, 5 and 8 are like a lowest term fraction. Binomials don't match. That's it. Okay?
How did you get 5?
Because 15 and 12 canceled out to 5 over 4. I divide them both by 3. It's like reducing a fraction diagonally.
Oh,
and then 4 times, there was a 2 here, so 4 times 2. And just a 5 was left on top and 4 times 2 on the bottom. So let's tackle this one. Same set of steps. We've got this rational bar, a complex fraction with a big rational bar. That's a grouping symbol. In order to just write that division horizontally, we need to use different grouping symbols, parentheses, and then horizontal. Now, is everything here, I know I'm going to, because of plus and minus, I'm going to need to deal with fractions, right? And common denominators. So in this bottom one, do I have all fractions? No. How am I going to handle just a number that's not a fraction?
What if you just put it over 1?
Exactly, yeah. Any whole number, any integer, any variable is rational. Just put it over, if it doesn't already look rational, just put it over 1. It doesn't change its value. Dividing by 1 doesn't change the value. But then it keeps everything lined up so you can treat them all like fractions. So write 1 as 1, but put it over 1. Okay. If this were a 2, you'd put 2 over 1. Right. If it was x, you'd put x over 1. Then plus 5 over x. Okay. Now, I can't just drop these parentheses like before because I don't have single rationals inside them. I have to clean them up first over a single rational, and I create that single rational with a common denominator. So, common denominator, product of unique factors in the denominators. Nothing to factor or worry about too much here. What is my common denominator for this first group? All right. So, LCD of 25x. And what's my LCD of the second group? Yeah, 1 times x, just x. So, make them match. To make this match 25x, I tack on an x there, and also then be fair to the top. This is like I multiplied this term by 1, because x over x equals 1. Multiplying by 1 doesn't change the identity. It's a legal move. Here, I got to tack on a 25. And so same thing here. It's all multiplication. Doesn't matter if you multiply in front of or behind. Just one on top, one on bottom. Here, do I need to change both of them or just one? Yeah, this one already has our LCD, so I'll just multiply this times 1 and this times 1. Just x over x. Now the whole point of doing this is to create a single rational. So now I write a single rational bar, and I put my common denominator. I no longer need the parentheses because since it's a single rational bar, the parentheses aren't necessary as a grouping symbol. What's my new numerator? X squared, right? That numerator is nice and flat. You just read it straight across. First numerator minus the second numerator.
How did you, why did you put it times x and then times 25 on the top? How did you know?
Because that is what a common denominator is. That's how we find a common denominator. It is the product of the unique factors.
Okay.
So this
I'm saying on the top.
Here, 25x.
I'm saying, why did you times x and why did you times 1 times?
Because in order to make 25 match our LCD 25x, we had to multiply it times x. There was a 25 here. We want it to be 25x, so I have to multiply it times x.
Yeah, the numerator.
It's only fair to do that if I also do it on top. Huh? Because when I did it on top, I was basically multiplying this times x over x, which is multiplying it times 1. And that's a fair move. I didn't change the value.
Whatever you do on the denominator.
Yes, however you make the denominator match, and then be fair to the top. Divided by, I'm not changing that yet, but my single rational, I can drop the parentheses because I have a single rational over x, and what's my new numerator? Careful, very
X
careful.
plus y.
Yes. This is an addition problem. It's first numerator plus or minus the second numerator. Very common mistake. Catch yourself in homework. Watch for that. This is not 5x, it's x plus 5. Okay. Now, flip, factor, and cancel. First I'm going to flip before I bother to factor. I can probably already see what I need to do. I'm just keeping this really clean. I mean, that stuff like that, you can sort of do it once when you're really confident with it. Okay. I'm just being really clean and laid out for the example. So I flipped, I multiplied times the reciprocal, and now I factor and lock up. Nothing to factor there, I just locked it up. Here I had a difference of squares. Anything that is not linear, your brain should go whoop, whoop, whoop. I may need to do something here. And for our purposes, if it won't be prime, you will be able to do something. Okay? If you see an exponent, except in a rare case where it's going to have another exponent that you just cross them out directly. But if you see an exponent, you should, I probably can factor that. I most likely can factor it. Difference of squares, conjugates.
Can you also, alright, so actually I'll just let you do it.
Okay.
Yeah.
Do what?
You're just going to do it right now.
Yeah, all right. So now that everything is flipped, factored, cleaned up, locked up, then we are back to a single rational bar because multiplication just means boom, it's multiplied. A single rational bar, you just need to cross out factors of 1 to put it in lowest terms. That goes away. 1x on top, 1. These x's are outside the parentheses, so that's fine. Those are factors. Okay, I can't cancel out these two x's because that's a term, that's a factor. This is locked up, that's not. But outside, those go away. X over x is 1. See, what's left on top is just x minus 5, and what's left on the bottom is just 25. Now, can I cancel out that 5 and 25? No. This is a term. If it's touching a plus or a minus, it's a term. This is a factor. It's just free floating. It's by itself. It's not touching plus or minus. You cannot cancel out terms, only factors. If you want to leave it locked up to help you remember, it all goes or none of it, that's fine. Nothing wrong with that. Okay? Okay. All right, so pushing ahead, because we want to make sure we did an extra example than I did in my morning class, and make sure we covered everything. So one of the, I was going to go over this kind of quickly. This is really just to break down this handout. It says 3 expression things on the front. This is just sort of a breakdown of what we've done. It's kind of this chapter can be very overwhelming and chaotic because there are lots of steps. The examples I've shown in class, this is just sort of a breakdown of the different things we've done and the basic steps. The order of these steps matters. There are other mathematical ways to approach things correctly, but the reason I choose these steps in this order is because I have found through experience it creates the least amount of chaos, the most organization, and the least number of careless mistakes. Okay? So pay attention to all of these steps in all this order. Whether the problem you're dealing with is very simple or very complex, it still follows the same steps in the same order. Okay? Now, so far we've been dealing with expressions. In 10.1, we also looked at the functions and how we evaluate the function and find the domain. Okay, you will see, like I said, some of that on the test. The rest of 10.1 was all about expressions that you just, a single expression you have to simplify, or multiply or divide. Two expressions, multiply or divide. Okay? And the set of rules for that. In this order, always. If it's division, flip first. Factor everything completely, including if you can't factor it, at least if it's a binomial, lock it up. Okay? And then cancel out factors of 1 or factors of -1. If you have opposites, that's a legal move. For example, opposites are both subtraction, it's just different order, x minus 4, 4 minus x. Okay? It's a legal move to cancel those out as long as you factor a -1 out of one of them, then that'll make a match. If you factor a -1 out of this, then you'd have x minus 4 left behind, and you could cross them out, but you'd have a -1 left behind. So when you cancel out opposites, what you're talking about is a factor of -1. Cancel them out, just immediately throw a negative in front of your problem. Doesn't matter where you put that -1, you can just put the negative out front. On 10.2, we did last time, we're adding subtracting expressions. Now those require common denominators. The LCD, the definition of an LCD is the product of unique factors of the denominators. Therefore, you cannot find the LCD until you have factored all the denominators. And as I suggested very strongly in here, this organizational technique of take your problem, the first step is to rewrite your problem with everything in the denominators factored and locked up, and with room to tack things on.
I have a quick question.
Uh-huh.
For room one.
Yes.
You factor out the -1 on each term, right?
Oh, up here? Yes?
Yeah.
Uh-huh. Well, yes. At this point, once you've multiplied or divided, remember, once everything's fully factored and division's turned into multiplication anyway, you've got one rational bar. Because remember I said when you multiply,
I mean, I'm saying you put it in front of the x -4, you put in the 1 and -1 in front of it. And
oh, you mean for the opposites here?
Yeah.
Yes, if you were to take a GCF out of this, you'd factor out a -1, which would turn what's left over into x minus 4. But so the x minus 4s would cancel out, but there'd be a -1 in front. And that -1 can go anywhere, on top or bottom. Best form is just throw it out front. It's going to change the sign of your whole problem. Is that what you mean? Is that what you're asking?
Yes.
Okay. All right. Okay. Okay, so after making that nice, long, tree-hating step there, you make your LCDs match, and then you set your LCD aside with the line over it, and you're going to then lift off your numerators, clean them up, factor, put it back on top, and if possible, put in lowest terms. Cancel anything else out at that point. Okay. All of that is there. 10.3, complex fractions, was really just mixing up adding, subtracting, multiplying, dividing. Okay. And I did change, when I first made this, I need to kind of update it. I changed the order a little bit to a way that I found was a little more easy to deal with. So this step right here, right is horizontal division. You know, lock up your numerator and your denominator. Lock up your numerator and denominator, and then write it horizontally, just like we have here. I moved that to the first step. Okay. I found that kept things cleaner. Okay. So this third one, move up here. Lock up your numerator and denominator and write it horizontally. And then, it's no longer numerator and denominator, so then you make your first group into a single rational expression over a common denominator, if necessary, and same thing with the second group. At that point, you can drop the parentheses, change division to multiply, flip it, factor completely, and cancel out factors of 1. Okay. So that's the summary of everything we did, the steps we do it in, and a strongly suggested order of steps.
So right first, make a group second.
This here?
Yeah.
So, oh yes, right is horizontal division, which means you've got your complex fraction. Lock up the top and the bottom because you're going to get rid of this grouping symbol, so you got to lock them up and write it horizontally. So once you do that, then If the first group is more than one rational symbol, get a common denominator and write it as 1. Same thing with the second. You want one rational line in both of them. Okay, so if you got something plus something or something minus something inside of a common denominator, it was like our second example here. You got pluses and minuses, you got to clean it up as one rational, then you can drop those parentheses, and then you can flip, factor, and cancel. Okay. Like I said, that's got a summary, and you know, those rules, like I said, strongly suggested order of rules and organizational techniques. Okay. Set that aside for a sec. And I'll be scanning this in and everything. This will all be loaded before I go for the weekend. All of these handouts and any sort of modifications made to them. Okay. All right. So the next handout. This is a little basic. It's more about thinking about things, and I think we kind of covered some of these things in examples that I didn't do in my earlier class. So let me just show you what I meant by this. I will scan in the completed version so you can sort of check yourself. This is the idea we're looking at here. Okay. The idea is not to solve these problems. And if you want to use these, some of these aren't ideal practice problems, but I can go ahead and solve these and post a solution page if you want to use these as extra practice. Okay? But that's not the point of this. The point of this was not to actually solve these, but to recognize what you have before you begin. You have to know where to start. You have to know what you're doing. Simplifying, multiplying, dividing, adding, or subtracting. Those are your operations. Simplify, multiply, divide, add, or subtract. Okay? And the rules and steps for each are different depending on what you have. So anytime you look at a problem, especially if you've got a mixed group of problems, you need to take a breath and make sure you're very clear on what you have and understand that depending on what you have, you've got a different set of rules or order of things to do. Okay? It's just like factoring. You take a breath and you think, where do I start? Well, GCF. And then count the terms. 2, 3, or 4 terms is going to tell you the method to use. And how do you know you're done? Okay? So where do we start with these if we have a mixed list is look at what you have. Really think, I got a rational, and what's my operation? Multiply, right? And sometimes you will have mixed operations. Some of the ones on the bottom have more than one operation. So when you fill in the operation blank, or when you think about it, think which one do I do first and which one do I do second? Okay? Because if you got more than one order operation, then the order of operations matters. Okay? And then this is a choice. If you are multiplying, you're going to do one of two things. Do you need an LCD, or are you going to factor and cancel? Factor and cancel. Huh? That's basically it. If your operation is division, will you need an LCD or factor and cancel?
LCD.
For division?
Oh, no. You still need the
Factor and cancel, yeah. But you might want to make a note, flip first.
So you flip first and then you factor?
Yeah. Mm-hmm. Let's go ahead and actually do this. Let's see how quickly we can do this. Go ahead and fill these in. We'll take 2 minutes. Okay? Because the idea is to be fluent, to look at what you have and be confident about what you're looking at. Okay? And if you have more than one operation, list them in the order that you do them. And I'll fill in as we go, and you can look up and check. These first 4 are just the basic 4 operations. Multiply and divide. You see, oh, I got a multiplication or division, so I'm going to need to factor and cancel. I don't need an LCD. But I did make a little note. If it's division, make sure you flip first, then factor and cancel. Addition and subtraction, however, you will need to factor the denominator so you can find the LCD. So when you say need LCD, that still means you're going to have to factor the denominators first, if necessary. Because you can't find the LCD unless you factor. Because the LCD is the product of unique factors. You can't find unique factors if you're not factored. So yes, factoring is involved in finding the LCD, But you're not just factoring everything and canceling out. You're factoring so you can find the LCD, make everything match, and then combine the numerators over that common denominator. What operation is in this one, this fifth one, first one on the third row? I mean, yeah, technically they're all division. Rationals have division bars, but you don't see a division symbol, right? Or a stack. Well, there's adding, subtracting on top and on bottom, but it's not in between other terms, right? Yeah, this is, and not to confuse things, if we look back at like this chart, we added, subtracted in 10-2. In 10-1 we multiply and divide, but we also just simplified. Yeah. Yeah. All multiplication and division is simplifying two rationals at the same time. Okay? Simplifying just means I have one rational. There's no need for a common denominator anyway because there's no other things to be common with. Okay? It's just like a multiplication or division, except instead of two numerators and two denominators to deal with, I just have one of each. Okay? Same techniques though. You just factor and cancel. The operation, not technically an operation, but the idea is all we're doing is simplifying. Here you can see the difference. Here's multiply, we've got something times something. Here, for simplify, we just have something. But the technique is the same, factor completely and cancel out any factors of 1. There's no addition or subtraction in this. Yeah, involved in the numerator and denominator, sure, but no plus another rational. Now we've got mixed signs. What order will we do these operations in? What are the operations and which comes first? Yeah, we'll end up going from left to right. Okay? Whenever you get down to addition and subtraction in PEMDAS, it's always in order of left to right. So in this case, subtraction comes first, and then add. But basically, once we have our common denominator, then all we're doing is writing our new numerator from left to right and cleaning it up, and then putting it back over the LCD. What are the operations here? And what do you do first? Parentheses, right. So addition, our operation here is addition, which we will do first, but we're allowed to do it first because of the parentheses. You're supposed to do it first because of the parentheses. And in that case, you will need an LCD. And after that, then what do we do? And for that, we're going to need to factor and cancel. So we're going to need both techniques. We do one first, the addition in the parentheses with an LCD, and then we have two terms. This will become one rational. The whole point of an LCD is make it over one rational bar, and then we'll have one rational times another rational. We'll multiply them, which means we have to factor and cancel. What operations do we have here?
Division.
Yeah, and? What comes first? Yeah, the parentheses, which can include adding and subtracting. So we can do those at the same time. So we're adding and subtracting. The parentheses tell us to do that first, okay? And then divide. And of course, for adding and subtracting, we will need our LCDs to clean this up over one rational and clean that. This is basically our already horizontal complex fraction. Clean this up over one rational with common denominators. Clean this up over one rational with common denominators. Common denominator of 3x, common denominator of 2x. And once these are over one rational each, drop the parentheses, and you can then factor and cancel when you divide. But of course, you're dividing, so flip first. Recognizing what you have, the different rules that come with it, and when you've got a mix of things, what order you have to do those things in. I say about math is that those are always the same. I mean,